JEE Advanced 2021, Paper 1, Question 2. Physics, Thermodynamics. Let us draw the pressure-volume diagram for this question. We have a rectangular cycle for an ideal gas on APV diagram. The cycle has 4 steps. Step 1, isobaric expansion from A to B at high pressure P2, where volume increases from V1 to V2. Step 2, isochoric cooling from B to C at constant volume V2, where pressure drops from P2 to P1. Step 3, isobaric compression from C to D at low pressure P1, where volume decreases from V2 to V1. Step 4, isochoric heating from D to A at constant volume V1, where pressure rises from P1 to P2. The question asks, an ideal gas undergoes a 4-step thermodynamic cycle as shown in the PV diagram. In which of the steps is heat absorbed by the gas? The options are option A, steps 1 and 2, option B, steps 1 and 3, option C, steps 1 and 4, option D, steps 2 and 4. The key concept is the first law of thermodynamics. Heat absorbed Q equals change in internal energy plus work done by the gas. For an ideal gas, PV equals nRT, so temperature is proportional to PV. For isobaric processes at constant pressure, Q equals NCP delta T. For isochoric processes at constant volume, Q equals NCV delta T. In both cases, heat is absorbed, meaning Q is positive, only when the temperature increases. Let us analyze each step. Step 1 is an isobaric expansion from A to B at constant pressure P2. Volume increases from V1 to V2. Since T equals PV over nR, and pressure is constant while volume increases, temperature increases. Therefore, Q equals NCP delta T, which is positive. Heat is absorbed in step 1. Step 2 is isochoric cooling from B to C at constant volume V2. Pressure drops from P2 to P1. Since volume is constant and pressure decreases, temperature decreases. Q equals NCV delta T, which is negative. Heat is released, not absorbed, in step 2. Step 3 is isobaric compression from C to D at constant low pressure P1. Volume decreases from V2 to V1, so temperature decreases. Q equals NCP delta T, which is negative. Heat is released in step 3. Step 4 is isochoric heating from D to A at constant volume V1. Pressure increases from P1 to P2, so temperature increases. Q equals NCV delta T, which is positive. Heat is absorbed in step 4. The correct answer is option C. Heat is absorbed in steps 1 and 4. In step 1, isobaric expansion at high pressure, temperature increases, so heat is absorbed. In step 4, isochoric heating at constant volume, pressure increases, temperature increases, and heat is absorbed. Steps 2 and 3 involve temperature decrease, so heat is released. Exam tips for JEE Advanced Thermodynamics. Tip 1. For an ideal gas, temperature is proportional to the product PV. So in any process, track how both pressure and volume change to determine if temperature goes up or down. Tip 2. For isobaric processes, Q equals NCP delta T. For isochoric processes, Q equals NCV delta T. Tip 3. If delta T is positive, heat is absorbed. If negative, heat is released. And remember, a clockwise cycle on APV diagram means the gas does net positive work on its surroundings. If you found this helpful, like and subscribe for more JEE Advanced 2021 solutions at MAGPIEHUB.